What I want to do is set the stage for defining conjecture. Okay, so let's talk about natural numbers first, since we've already discussed that that is the first set in the pecking order of determining this real number system. Let's just go ahead and look at some natural numbers and some concepts of how we can determine what a conjecture really is. So we know that natural numbers are counting numbers, 1, 2, 3, 4, 5, 6, 7, and so on. And if you look here, you'll see that I have 3 dots behind the number 8. These 3 dots are known as an ellipse. Okay, so this means simply that 8 is not the last number in the sequence, and it will continue forever in the same pattern, which is adding 1 to it. A word we should also know is the word divisibility. Okay, we should all know what that means. But those of us that do not, divisibility means that if you divide a number by a number, you would get a remainder of 0. Now keep in mind, we're only talking about natural numbers here. So we have 2 types of natural numbers. We have even and odd. Okay, even natural numbers are divisible by 2. Okay, keep that in mind. So counting numbers that are divisible by 2 are not, so let's go ahead and change this and say that are not divisible by 2 are known as odd numbers. So recognizing this pattern, it really can help us solve some problems. But one of the first things we want to look at is what is a conjecture. So let's just take a look at a hypothetical example. If you have 2 even numbers and they're multiplied together, will the product always be even? Well, I don't know. Let's see. So let's take an example, and let's take the very first even number. So 2 times 2. Okay, that's going to give us 4. Let's take 4 times 6. That gives us 24. Okay, we're going okay so far. Let's take 6 times 8. Okay, and that equals 48. Let's take 2 times 4, and that does equal 8. Let's take 4 times 8, and that equals 32. So far we're doing okay, right? Let's take 6 times 10, that equals 60. Let's take 2 times 6, that equals 12. Let's take 4 times 10, and that equals 40. Okay. Let's take 6 times 12, and that equals 72. Let's take 2 times 8, and that equals 16. Let's take 4 times 12, that equals 48. See the pattern so far? Let's take 6 times 14, and that will equal to 84. Okay, so if we just stop here, we don't have to, but if we just stop here and we literally look at this pattern, what we will see that all our products, 4, 24, 48, 8, 32, 60, 12, 40, 72, 16, 48, and 84 are all even numbers. Okay, so we can come to the conclusion simply by what we worked. Are these all the problems? No, but we took quite a few and we worked these problems. Actually, we took 3, 6, 9. We took 12 problems. That's quite a few, and we worked those 12 problems, and we still came out with even numbers. So we can come to the conclusion by saying, from what we have here, that all the products are even. This is just for our sample. So we can say all the products are even. Okay, so now, so just by using from what we've seen, from what we've worked, we can predict, or we can come to the conclusion that all of the products of two even numbers will give us an even number. Okay, so this is what we did here, and we can predict, predict, we can predict that the product of all even numbers is an even number. Okay, now are we true? I mean, would we necessarily say that this is correct? Well, we don't know. What we're doing here is we've just actually taken what is called an educated guess. So what we've done is we've taken an educated guess or go ahead and do something with this not so SS here. Bear with me, he's not through with me yet. We've taken an educated guess, or what is known as a conjecture. A conjecture. So when we look at an experiment and we come up with an experiment and we look at what the solution to the experiment is, and we determine from the experiment what we perceive as the right answer, we are actually completing a conjecture, or what is known as an educated guess. Okay, so what I'm going to do next is I'm going to put up an example, and I want you to work that example, and then you determine your conjecture.